All right, this is your geometry semester exam, page 5. For number 19, it says determine which statements are true. It's not multiple choice, so we're answering each question. For A, DE is congruent to GF. First of all, over here to the side, it tells us that this is a rectangle. So we know that all parallelogram rules apply and all rectangle rules apply, right? So both pairs of opposite sides are parallel and congruent. All four corners are 90 degrees. Our two diagonals are the same length, and the diagonals bisect each other. So this is congruent to this, and this guy would be congruent to this guy, since these are congruent to each other. All right, so A, DE is congruent to GF. DE is the top, GF is the bottom. They're opposite sides, so yes, that is congruent. That's true. B, EF is congruent or equal to DG. DG is this side, EF is this side. So yes, those are opposite sides. They are congruent. That is true. C, FL is congruent to EL. FL is this guy. EL is this guy. Yes, all of these half diagonals are congruent to each other. If this entire diagonal is 10, that means it's split up into 5 and 5. If this diagonal is 10, this diagonal has to be 10 as well, because in a rectangle, diagonals are equal. So this would be 5 and 5, right? So they're congruent to each other. So yes, this is true. D, triangle DLG, DLG, this little guy here, is congruent to ELF, ELF, this little guy here. Yes, it's like bow tie, right? This is the same length as this. These are the same lengths as these guys, so they're congruent to each other. These two little vertical angles are congruent. That is true. E, DEG, DEG, so this half of our rectangle, right, this guy, is congruent to FLG. FLG is congruent to just this little bottom. If it was congruent to this entire thing, then yes, this entire half would be congruent to this entire half, but this entire half is not congruent to just this little part, right? So that is not true. That's false. And then F, angle DGF, DGF, this guy, is congruent to, or is a right angle? Yes, it is. This is a right angle because it's a rectangle and all four corners of a rectangle are right. So this is true. So the only one that was not true here was E. It was false that triangle DEG and FLG are congruent. Number 20, explain how to prove triangle MNP and ABC are congruent. If you look at these two triangles, this is kind of like an obscure rule that we didn't focus on too much, but it is true here. These are both right triangles, okay? And in these right triangles, they both have one leg that's congruent to each other, and the hypotenuse is congruent to this hypotenuse, right? So in a right triangle, only right triangles, not every triangle, just right triangles, if it has the hypotenuse and one leg congruent to the hypotenuse and one leg in another right triangle, then the two triangles are congruent because of the HL rule, the hypotenuse leg rule. So we don't have to do anything, right? HL rule. They already are congruent. We just had to show that one leg is congruent to one leg, and the hypotenuse is congruent to the hypotenuse, and that they're both right triangles. All right, my battery's going low. And then number 21, it says match the pairs of equations with the description. So A, 8x plus 4y equals negative 8, and y equals negative 2x plus 6. So our descriptions are the lines are parallel, the lines are perpendicular, or they're neither one. So we need to look at the slopes of each line, right? Here, the slope is negative 2. So we got to figure out, well, what's the slope in this guy? Well, to know the slope, we need to get y by itself, right? So we need to rearrange it. So I'm going to do it in just this little open space up here since I have it. 8x plus 4y equals negative 8. I'm trying to get y by itself. Let me pull this down just a little bit. So minus 8x from both sides. So I get 4y equals negative 8x minus 8. And then I'm going to divide everything by 4, right? So I end up with y equals negative 8x divided by 4 is negative 2x. Negative 8 divided by 4 is negative 2. And this does have the same slope. Negative 2 is the same as this negative 2. They have the same slope, which means they are parallel. So it goes with this one. Number 2. B, y equals 3/4 x minus 1, and y equals negative 4/3 x plus 3. So the slope is the number in front of x. One of them is positive 3/4. One of them is negative 4/3. What do you notice about those? We flipped the fraction upside down and we changed the sign in front, right? So not only are they different, they're actually negative reciprocals, which means they're exact opposites. They are perpendicular slopes. So this guy goes together. B goes with number 3. And then lastly, and we kind of figured it out already, it's got to match up with number 1, 5x plus 5y equals 0, and 5x minus 3y equals 1, right? And we've got to get y by itself here. You can't just assume that if the number in front of x is the same, this works. It has to be in slope-intercept form for this to work. So if you were going to mathematically get y by itself, this equation would end up being y equals negative x plus 0. And this one would end up being y equals, not 3y, just y equals, and that would be 5/3 x minus 1/3. Right? So the number in front of x, in this case, it's negative 1, and in this case, it's positive 5/3. They have absolutely nothing to do with each other. They're not the same. They're not negative reciprocals. They're just nothing. So it goes with number 1. They're not perpendicular or parallel. Okay, so you got to get y by itself to figure out if the number in front of x, the slope, is the same, is exact opposites, or isn't anything whatsoever. Number 22, given the following points, describe the relationship between lines A, B, and C, D. All right, well, we could find the slope of the line since we're kind of already talking about parallel and perpendicular lines. So let's first find the slope of AB. Okay, so we're going to do for AB, y minus y, 7 minus 1, over x minus x, negative 4 minus 2. 7 minus 1 is 6, negative 4 minus 2 is negative 6, so the slope is negative 1. Okay, and then we're going to look at CD. So the slope of CD, y minus y, 2 minus 5, over x minus x, negative 2 minus 1. Remember, it doesn't matter which y you start with on top, but whatever y you start with on top, you have to start with its partner first on the bottom. So since I started with 2 on top, I had to start with negative 2 on the bottom. I could have started with 5 on top, 5 minus 2, and then I would have had to start with positive 2 on the bottom, right? Doesn't matter. Okay, so 2 minus 5 is negative 3. Negative 2 minus 1 is negative 3. Negative 3 over negative 3 is, oops, that was a bad mistake, positive 1. Positive 1, not negative 1, positive 1. So what's the relationship between negative 1 and positive 1? Well, aren't they negative reciprocals, right? Negative 1 over 1, if I flip it upside down and change the sign in front, doesn't it become positive 1 over 1? Yep, so these are perpendicular lines. They have negative reciprocals. So it said, given the following, describe the relationship. We would just say perpendicular. That's all you have to say. If you wanted to take it a step further and find the length of each line, you could tell whether they are congruent or not. But in this case, we're just going to tell if they're perpendicular or parallel or neither. All right, number 23, describe the relationship between the two lines y equals 3 and y equals negative 4. Okay, well, if we were to graph a y equals problem on your y-axis, let's say this is the x-axis, right? On the y-axis, you would just find that number. Y equals 3, I'd go up 1, 2, 3, put a dot. There is no x in this equation, which means I'm never going to cross the x-axis. So this is always, a y equals a number is always a horizontal line. This is also y equals a number, 1, 2, 3, 4. So I'm going to go down like this. So both of these lines are horizontal, which means they have the same slope, which means they are parallel. Parallel and horizontal. Easy peasy. Number 24, describe the relationship between these two lines, okay? If I look at this first equation, the slope is 2. If I look at the second equation, the slope is negative 1 over 2. So what do you notice about the slopes? They are negative reciprocals. Flip 2 over 1, and you get 1 over 2. Change the sign in front, you get negative 1/2. They are negative reciprocals, so they are perpendicular. Perpendicular. They're exact opposites. They intersect at 90 degrees. 25, describe the relationship between the two lines x equals 5 and y equals -2. Well, remember, y equals a number is a horizontal line. And since y equals a number is horizontal, what do you think x equals a number is? That's a vertical line. X equals a number is always a vertical line, right, when you're graphing it. So what's the relationship between a vertical and a horizontal line? Don't they cross at 90 degrees? One's vertical, one's horizontal. Don't they cross at 90? Yes, they do. So they are perpendicular. I want to put that U and the L together. Perpendicular. Okay. Number 26, find the equation of the line in slope-intercept form. That's y equals mx plus b. You got to know that for your test. Of the line that passes through -2, 6 and is parallel to y equals 3x minus 1. So first thing we know is that it has a slope of 3 because it's parallel to a line that has a slope of 3. So our line, first step is always to find the slope. Y equals 3x plus b. That was step 1. Done. Next step, step 2, is to figure out the y-intercept, right? So to figure out b, I got to plug something in for x and y. Well, it tells me that my line passes through -2, 6. So when x is -2, y is 6. So 6 equals 3 times -2 plus b. Now I can solve for b. 6 equals -6 plus b. Add 6 to both sides, so b must equal 12. B equals 12, okay? So then step 3, now I know that this is 3 and I know B is 12. So now I just put it together. Y equals, this is step 3, Y equals 3x plus 12. That's the equation of my line. So writing a y equals mx b equation is always step 1, find m. Either it gives it to you or it gives you information to solve mathematically. Step 2 is to find b, the y-intercept, which normally you just have to plug in something for x and y to solve for b. And then step 3 is to put it all together. So your final answer cannot have the letter m or the letter b in it. If it does, then you didn't finish it, okay? You always replace m and b. Last question for this page, number 27, find the equation of the line in point-slope form that passes through 0, 2 and is perpendicular to y equals 1/2 x, blah, blah, blah. Okay, so point slope, remember, is y minus y1 equals m times x minus x1. M is our slope. Y1 and x1 are the point on our line. So I dried my yellow marker out last night. I have no yellow. I have to use the ugly orange and pink, but that's okay. So I'm replacing these things that I'm highlighting, right? In pink, I have x and y, which is a point on my line, and in orange, I have the slope of my line. So it says my line is perpendicular to a line with a slope of 1/2. So if I flip 1/2 upside down and change the sign, I get -2. So my line has a slope of -2. Y minus something equals -2 times x minus something. And then my point on my line, it tells me, is 0, 2. It passes through the line 0, 2. So when x is 0, y is 2. So I plug a 2 in for y, a 0 in for x, and I'm done. That's my line in point slope form. If you start simplifying, it's no longer going to be in point slope form. Point slope literally has the slope here and then the y and the x of a point on the line, and you're done. This is a 0. All right, let me know if you have questions.